Most satellites are not what we might think. The Moon is a satellite of Earth, Jupiter is a satellite of our Sun, and Kepler 186f is a satellite of Kepler 186. But typically we refer to satellites as the man-made objects we place in orbit for our use. How do you make a satellite? Since satellites are used from everything to studying our universe to transmitting television programming, it'd be fair to say that constructing one requires a small feat of engineering. But really, all you need is a power source and a means of communicating with the device remotely. Pause this media now while you construct your satellite. Great, your device is now ready, but it isn't really a satellite while it's here on Earth. Find the nearest Delta II launch vehicle and let's prepare to get your device in orbit. First, point the correct end of the rocket towards space. Second, launch your rocket. As your rocket is leaving the thickest parts of our atmosphere, don't forget to gradually pitch sideways to add a component of horizontal velocity. Assuming you took proper steps to notify the US and Russian militaries and heaven at this point triggered a nuclear war, your rocket should now be on a suborbital trajectory. That is, it will reach space, but it will still fall back to Earth. Velocity is now key. Too much thrust and your device will escape the Earth's gravitational sphere of influence and become a satellite of the Sun. This is called escape velocity. If you can burn your thrusters just right, you will have enough horizontal velocity that as you fall back to Earth, you will fall around the very curvature of the planet. Congratulations, your device is in orbit. It's now a satellite. I said velocity is key, and I meant that. You see, velocity determines the altitude and shape of the orbit. The closer your satellite is to the Earth, the faster it has to be traveling to maintain its orbit. Far away objects move slower. If you think about it, this means there is a certain altitude at which a satellite can orbit at the same rate the Earth rotates. This altitude happens to be at 35,786 kilometers, and this is called the geosynchronous orbit. To an observer on Earth, a satellite oriented in such an orbit above the equator with 0 degrees inclination will stay in the same spot in the sky at all times. This is a specific type of geosynchronous orbit called the geostationary orbit. If you've built a communications, broadcast, or meteorological satellite, this would likely be the best orbit to place it in. But hop to it. Geostationary orbital positions are in limited supply.